Now we want to talk about how is it that I could actually find the mean and the standard deviation for a discrete random variable. Well, first it should be important for us to consider what exactly we are talking about when we talk about finding the mean of a random variable. Let's suppose here again that x still represents the number of episodes that I'm going to watch throughout the rest of this week. Well, you might want to know if I was to kind of repeat this experiment of saying, like, how many episodes am I going to watch next week and the week after and the week after that, you could start to imagine that I could create an average number of episodes that I watch per week, or what we also call the mean number of episodes, or the expected number of episodes, or the expected value of my discrete random variable. So what you'll see here is that I have two bits of notation to help communicate these two different ideas. When I talk about the mean, I have my classic symbol with my mu, and now just a subscript of x to indicate that this is the average for the random variable of x. I also have, though, here a symbol or a phrase of expected value for my random variable, which is noted with this e of x notation. Now, we won't be utilizing this e of x notation very often. Very often we'll be using this green notation instead. However, the phrasing up here in blue will be used very frequently. We'll often talk about the expected value of a variable. And when we hear that word expected, we should automatically be associating that with the word mean or average. Now, there's a formula over here for how to calculate this, but we'll see that this formula is not actually going to be very necessary for us because the calculator will use that formula to calculate our average after we just do a couple quick calculator entries. The other thing that we have here is the variance of our discrete random variable. Remember, that's just going to be the square of our standard deviation. The calculator is going to be using this complicated formula over here to calculate our variance, and our standard deviation is, of course, just going to be the square root of that value. Now again, we will never really have to find these values by hand. Instead, we're going to use the calculator to quickly find both of these values. And I have commands here for exactly how I would go ahead and do that. I would enter the values of x and the corresponding probabilities into two separate lists on my calculator, L1 and L2. And then I would use this one_var stats command to find the mean and standard deviation for my distribution. So let's take a look at how to do that. But before we jump to the calculator, I want to take a look here again at the formula sheet. Notice again that in our first column here, the mean and the standard deviation are labeled as the parameters of the distribution. And also that they only really ever need to be found if we're being asked to find them, like we are in the question that we're currently looking at. Now, notice here as well that instructions are given, much like the ones that are in the box on the page of the notes, that tells us exactly what we have to do. We have to run a one_var stats with list 1 and list 2 in order to have the calculator generate these values. So let's go ahead and actually go to the calculator and try to acquire the values of the mean and the standard deviation by using this one_var stats. So let's look ahead at example number 3 to see what our goal is here. I want to return to problem number 2 and find the expected number of episodes that Kyle will watch. Remember, expected, we associate that with the mean or the average number of episodes that Kyle will watch, and the standard deviation, and then interpret the values. Okay, so let's go to the calculator. All right, once I'm at the calculator, I can see here that I've already pulled up here my lists in my calculator. And I want to go ahead and just start entering in, say, all of my x values from my table on one side, and all of the associated probabilities that go with this on the other side. So these are all the values that we got back in example number 2. Now, once I have all these values entered, I can go ahead and click the Stat button, go back to Calculate, click one_var stats. If I have my fancy calculator menu like this, I can go ahead and do list 1, and then I would go down to this frequency list. This is where I'm going to list my probabilities. So my first list is for my x's, my second list is for my probabilities. And so I'm going to insert L2 there. Then I can go to Calculate, and I will end up with these values. Now, really quickly, if you don't have that fancy calculator menu, then what you're going to see again on your calculator screen is something a bit different. You would see something that actually just looks like this. You would have one_var stats on your main screen, and then you would have to type in L1, then put in a comma, and then type L2. And then all those same numbers should appear once you hit enter. Now, if you're having difficulty finding the comma button, keep in mind that it's right here above the 7. So that's where I would click it in order to insert a comma. So once I have these values, I can go ahead here and I can write them down. And I'm going to make sure that I use the appropriate symbols. So I have my average for the random variable x, and the calculator tells me that that number is 1.87. Notice the calculator here is using the incorrect symbol, and so I have to make sure that I correct that symbol to the mu of x symbol. And so I have that written here, and this is 1.87. I'll put units on it. Those units would be episodes. So we would expect that I would watch about 1.87 episodes. Notice my standard deviation for the random variable of x. Notice the calculator even kind of has that little subscript kind of put there, although it doesn't look like a subscript on this screen. But it has this value, 0.9865, if I round to 4 places. So 0.9685. And again, the units there are still episodes. So the idea here is Kyle should, on average, watch about 1.87 episodes, but don't be too surprised if he watches this many more or less than average, because that seems to happen all the time. So if I was going to interpret these values, I would say something like this. On average, Kyle will watch 1.87 episodes, but it is not uncommon for him to watch 0.9685 episodes more or less than average. Notice this is the same idea that we had established a long time ago when we introduced the concept of the mean and the standard deviation as kind of a pair. If my mean is sitting here in the middle, it's not surprising to take my standard deviation value and go up and go down, and then say that it's pretty typical for Kyle to watch a number of episodes somewhere in between this interval. Okay, so that's it. This is how I can find means and standard deviations.